we're going to start looking at example SPSS data printouts. So again, this is statistical software. It's been around forever, different versions of it, but I think the very first edition was published in 1968. Even what SPSS stands for has changed over the years. Currently, they gave it a very corporate name, Statistical Product and Service Solutions. It's statistics software. So if we were doing a real research study, not our little example homework problems, you wouldn't want to do it with a calculator. You can have hundreds of people in your sample and multiple hundreds of data points. So we're going to put this all into a computer program. You can do most of the same work in Excel, and there are other packages out there, but SPSS tends to be, particularly in the United States, the most commonly used stats. So I'm not caring about you learning to program it, but when you see the results, you should know how to read those. So let's take a look there. On page 261 at that bottom, figure 9.9, that whole little box there shows us a lot of information. And there's two boxes. So at the top says one sample statistics, and at the bottom it says one sample test. Well, this is a single sample t-test. We know that for a couple reasons. First, it's a single sample t-test chapter. It's chapter 9. But it's telling us it's a one sample test. That's its way of telling it's a single sample t-test. So we're going to focus on that bottom box. And so we can see it says variable 1, 0, 0, 0, 0, 0, 1, variable 1. There's a box for t, box for df, box for sig, two-tailed it says, mean differences, and then there's some confidence interval stuff. So let's just focus on the things relative to what we've learned in this class. So if you look at that, I should be able to ask you, what was the value of the t statistic? And the t statistic, we can see in the second box there, is negative 2.667. Notice it's reported to 3 places. We use 2, but same difference. So what value did they get when they did the math for the t statistic? Negative 2.667. You should be able to look at this and I should be able to ask you, well, how large was the sample? How many people were in this study? Well, we look at the second box and it tells us degrees of freedom is 8. Well, for that chapter, what's degrees of freedom? N minus 1. N tells you the size of the sample, number of scores in the sample. So if N minus 1 equals 8, N must equal 9. So we would know there were 9 people in this study. Was this a one-tailed test or a two-tailed test? Well, it says right in the very next box, sig, and then in parentheses, two-tailed. That pretty much indicates it was a two-tailed test. If they ran it one-tailed, it would say sig one-tailed. Now, the only part that's a little bit different for us, it's not quite as obvious. What you and I have been working with all semester is preset alpha levels of 0.05 or 0.01. And then we finally, we use that to define our critical regions, and are we in the shaded area or are we not in the shaded area? Are we in the tail or in the body? Well, what these programs report is the alpha level at which statistical significance would be achieved, not what the standard was. So if we look here, what it tells us when it says sig two-tailed is 0.029. Yeah, 0.029. So let's think about that. Again, let's use a one-tailed test as an example because it's just easier to visualize. If we had an alpha level of 0.05, then we know we are looking for the extreme 5%. Could be right or left, but I'm used to drawing it on the right, I guess. Right? 5%, the extreme 5%, if that was an alpha level of 0.05. As a proportion, 0.0500. Well, where does 0.029? Think about this. We have to think about it a little bit differently than regular t-scores or f-scores or whatnot. Here we were looking for the top 5%. The top 5%, the extreme upper 5%. And where did our sample land? Turn that into a percentage. Well, if we turn that into a percentage, it's telling us that it was at 2.9%. So we're looking for the top 5%, and our sample was in the top 2.9%. So the decision would have been to reject the null hypothesis. So that little tag sig up there tells you what level of significance they have, 0.029. Doesn't tell you the results are significant based on any other standard. If we were doing a 0.01, an alpha level of 0.01, we'd be looking for the extreme 1%. Is our sample in the extreme 1%? No, they're in the extreme 2.9%. They're back here. So if we were using an alpha level of 0.01, the decision would be to fail to reject the null hypothesis. So this is just a different way of reporting it that's not uncommon. Sometimes researchers report it the way we've been doing all semester, and sometimes they report something that looks more like this. So we just have to think about it for a minute to figure out, is it significant and at what level relative to how we've been working it. So that's the first example here. I'm going to start a clean clip for the second example in just one moment.